Hi guys, in this lesson we are going to be discussing linear algebra. So this is going to be the first lesson on linear algebra. Now guys, the first topic we are going to discuss on linear algebra is what we know as integer exponents. What are integers? Integers is a number with no fractional part, that is whole number. Then what are exponents? It is basically how many times the base can multiply itself. Okay, so this is what we know as exponent. Now if you take a look at the screen, we're having properties of integer exponents. Guys, we are going to be using this rule to evaluate integer exponents. Okay, so let's take a look at the first example. And guys, the first example we have here is 4s raised to the power of -4, then multiply y raised to the power of 5, then all raised to the power of 3. Now guys, we want to evaluate this integer exponent. So we're going to be using one of these rules. What rule do we need to apply here? What rule do we need to apply? Now guys, we are going to be using the fourth rule. As you can see guys, we are going to be using this rule. Okay, so because we're having the values inside the parentheses raised to the power of 3, so this power of 3 is going to multiply everything inside the parentheses. So this is going to be equal to, so this is going to be 4 multiply s raised to the power of -4. Okay, -4 times 3, this is going to give us -12. Okay, so this is -12. So this is -12. Then multiply y raised to the power of 5 times 3. This is going to give us 15. So this is y raised to the power of 15. Okay, so this is y raised to the power of 15. Now guys, make sure you don't forget this 3 is also going to multiply this 4. Okay, so this is going to be 4 raised to the power of 3. Okay, so this will be 4 raised to the power of 3. 4 raised to the power of 3 is going to give us 64. So instead of having 4, we are going to have 64. So let me erase this because we're having a constant 4. So it's going to be 4 raised to the power of 3, which is 64. Okay, so we're having 64s raised to the power of -12, then multiply y raised to the power of 15. So guys, this is going to be equal to 64, then multiply s raised to the power of -12. This can also be written as 1 over s raised to the power of 12. Okay, so this can be written as s raised to the power of -12. If we use the seventh rule, okay, so this is going to be equal to 1 over s raised to the power of -12, then multiply by y raised to the power of 15. So guys, we can write this as 64y raised to the power of 15, then divide s raised to the power of 12. So guys, this is going to be the final answer. Okay, so let's take a look at another example. So the next example we have here is -10 multiply z raised to the power of 2, then multiply y raised to the power of -4, then raised to the power of 2, then multiply z raised to the power of 3, then multiply y raised to the power of -5. And guys, the first step we're going to take is we're going to try to evaluate the first term. Okay, so we're going to use the second rule. Okay, as you can see, we are going to use this rule. So we are going to multiply the exponent, which is 2. We are going to multiply it with the values inside the parentheses. Okay guys, so if we multiply this is going to be -10 raised to the power of 2 is going to give us 100, right? So this is 100, then multiply z raised to the power of 2 multiply 2, right? So 2 multiply 2 is going to give us 4. So this is z raised to the power of 4. Then multiply y raised to the power of -4 times 2 is going to give us -8. Okay guys, so you need to make sure that you are going to multiply the exponents. Okay, so you are going to multiply the exponents. So it's going to be -4 times 2. Okay guys, So this is 100z raised to the power of 4, then multiply y raised to the power of negative 8. Okay, so this is multiplied by, as you can see guys, we're also having negative 5. We're having negative 5 on the exponent, so we're going to multiply negative 5 with the values inside the parentheses. Okay, so this is going to be z raised to the power of 3 multiply negative 5 is going to give us negative 15. So this is z raised to the power of negative 15. Then multiply y raised to the power of negative 5. Okay, guys? So this is going to be 100. Then multiply. As you can see, guys, this is going to be z raised to the power of 4. Then plus minus 15. Okay? So this is going to be 4 plus minus 15 because we're having similar base, which is z, right? We're having similar base, which is z. So we're going to take one of the base. Okay, guys? So we're going to take one of the base. Then we are going to add up the exponents because we're having multiplication of 2 integer exponents. Okay? So this is going to be 4 plus minus negative 5. So this is basically 4. This is basically 4 minus 15. Okay? So this is 4 plus negative 15. It's going to give us 4 minus 15. So 4 minus 15, this is going to give us negative 11. Okay, guys? So we're also having y, then raised to the power of negative 8 plus negative 5. So this is going to give us negative 8 minus negative 5. Okay? So negative 8 minus negative 5 is going to give us negative 13. Okay, guys? So this is going to be the answer. So this is the answer. So let's take a look at the third example. Okay? So let's take a look at the third example. Oh, guys, you can also write this as 100, then divide z raised to the power of 11, then multiply y raised to the power of 13. You can also leave your answer like this. Okay? So now let's take a look at the third example. So we have n raised to the power of negative 2, then multiply m, divide 7m raised to the power of negative 4, then multiply n raised to the power of negative 3. Now guys, what we need to do is, this is going to be n raised to the power of 4 on the numerator, then n raised to the power of 3 on the numerator as well. Then we're also going to have multiply by m. Because guys, the values on the denominator, as you can see, we're having m raised to the power of negative 4. So if you take the reciprocal of this is just going to be m raised to the power of 4. Also, if you take the reciprocal of n raised to the power of negative 3, this is basically just going to be n raised to the power of 3. Okay? Then we're also having m. So this is divided by, 7. Now guys, n raised to the power of negative 2. If you take the reciprocal of this is going to be n raised to the power of 2. Okay? So this is going to be on the denominator. So this is 7n raised to the power of 2. Okay? So this is going to be equal to m raised to the power of 4 multiply m is going to give us m raised to the power of 5. Okay? So we are going to take one of the base, then we are going to add up the exponents because we're having multiplications of 2 integer exponents. Okay, guys? So this is m raised to the power of 5. Then multiply by, now guys, as you can see, we're having, let me write this with red. So let me indicate this with red. So this is n raised to the power of 3, then divide n raised to the power of 2. Guys, this is going to give us n, right? N raised to the power of 3 divide n raised to the power of 2 is going to give us n. So we're having n. So this is n raised to the power of 5, then multiply n. Okay? So this is going to be divided by 7. So this is going to be the answer. So let's take a look at the last example. So the last example is z raised to the power of negative 5, then divide z raised to the power of negative 2, then multiply s raised to the power of negative 1, then all raised to the power of 6, right? So all raised to the power of 6. Now guys, we are also going to use the same logic. So this is going to be equal to, now guys, s raised to the power of negative 1. If you take the reciprocal of this is basically going to give us s. Okay, so this is going to be on the numerator. We can also write this as s raised to the power of 1. So this is s raised to the power of 1. Also, z raised to the power of negative 2. If you take the reciprocal of this is basically going to give us z raised to the power of 2. So we can place this on the numerator. So this is z raised to the power of 2. Okay, now guys, z raised to the power of negative 5. If you take the reciprocal of this is basically going to give us z raised to the power of 5. So we're going to place this on the denominator. So this is z raised to the power of 5. Okay, so this is all raised to the power of 6. This is all raised to the power of 6. Now guys, this is going to be equal to z raised to the power of 2 divided z raised to the power of 5. This is basically going to give us z raised to the power of 3. Okay, so we're going to place this on the denominator. So this is sorry guys, not z. This is s raised to the power of 1. Then divide z raised to the power of 3. Then all raised to the power of 6. We are going to take the exponent, which is 6. We are going to multiply this exponent with the value inside the parentheses. Okay, so we're going to multiply it with the numerator. We're also going to multiply it with the denominator. Okay, so doing this, we are going to have s raised to the power of 6, then divide z raised to the power of 6 multiply 3 is going to give us 18. So this is z raised to the power of 18. So this is going to be the final answer.